Okay, it's 8 o'clock. We'll get started. We are not going to wait for other people. Anyway, we are actually get started for the competitive programming last time. And today we are going to continue. And before we continue, I have to talk about it again. Number one, competitive programming. Okay, competitive programming basically is majorly in the problem solving. Okay, it's in problem solving. And then the name is called USSA Computing Olympia. So it's a Olympian activity. That means that not everyone should go. Actually, a lot of students doesn't qualify for competitive programming. Okay, so if you don't feel you belong to here, you don't need to work too hard. Okay, it's okay if you don't feel comfortable about it. Only selected people need to come here. That's number one. Second, do you need to have the competitive programming if you want to do a CS major? This one I would say, of course, because all the core CS people need to work on the algorithms. So competitive programming is a necessary item for CS majors. So if you are not suitable for competitive programming, that also means you're not suitable for computer science major. Okay, that's actually very apparent. Anyway, that's just some word before we get started again. And today we actually continue our discussion about competitive programming. So last time we talked about what is competitive programming, and there are 5 types of the programmers, and we want you to become a higher level programmers. Okay, and today we are going to get started for the ad hoc algorithm. And last time we talked about the basic idea of ad hoc algorithm. So ad hoc algorithm is one of the problem type in competitive programming. So programming means that you set up a problem solving way, but there are many different type of a problem, and ad hoc problem is one of them. Okay, so basically programming means that you actually have a way to solve your problem, and that way is your programming. Okay, so it can be dynamic programming is one way you work on it. Greedy algorithm, complete search. These are different ideas of how to search through the problem space. And ad hoc problem is one of them. Okay, it's only one of them. So what is ad hoc algorithm? Ad hoc program means that a problem may actually just have a certain specific way of solving it. And that solution is actually existing and well studied to solve the problem. Okay, if you don't follow the same way, it would be more difficult to solve. So this type of problem, we call it ad hoc problems. And ad hoc problem usually has no category. It can be anything. Okay, it can be anything. So first one, let's look at this problem called greedy gift giver. So this greedy gift giver is actually in the ad hoc problem. This one, section 1.2, this greedy gift giver. Okay, let's look at this problem and how it is a ad hoc problem. Okay, let's look at the problem statement. So this problem start with a few people. So there are a group of people. This NP is number of people. Okay, so number of people can be between 2 and 10, and each one has its own name. So they are named for each one of them, and then each of these friends might or might not give the money to some or all of the other friends. So every time it will be one person will give money to the other ones. Likewise, each friend might or might not receive money from any or all of other friends. So This one is actually giving money among the friends, and then eventually calculate each one has how much money. So this one, the goal is to deduce how much more money each person receive than they give. So the rule of the gift giving is potentially different than you might expect. Each person go to the bank. Okay, so there is a bank for each person. So let's assume that you have the people A, B, C, three people. Okay, and then okay, and then B may have seven. Let's assume that A has $7, and then he would divide it to two people when he would use this $7 and then divide it to two people. So you give to B for $3 and give to C for $3. And then there's $1 remaining. Okay, so the $1 would return to the A. Okay, so after the first transaction, the A, B, C, A has $1 left. Originally has $7. That's the original B $0, C $0. And after the first transaction, this is $7 being split into 3 to B, 3 to C, and then one remaining dollar remaining at the A. Okay, so that's how the transaction should be. That's the rule that they give away the money. Okay, so that's the way to give up the money. And then, okay, so the input format is called give one the in. So there's a line one, there's a single number of the people. So how many people you expect will be NP, okay? And then after that will be the name of each person's name. So there's totally NP strings. And then there are transactions. So let's look at the example. So let's assume that actually this is an input file. So totally 5 people. So the first line you have a 5, then the 5 people's name. And then this one is, let's assume you have a D for Dave, Laura, Owen, Vic, and okay, whatever. And then Dave actually here it has 300 and 203. So you would check initially everybody had $0. And then let's see. This first one is the name of the people who will give away the money. And then let's read the second line. So then actually the first line of each group is the person name who will give a gift. Second line had 2 numbers, the amount of the money to be divided into the gift by the giver. So the giver would take away $200 from the Dave. And then you give away the second number. The first number is the money to be divided. Second number is the number of people whom the giver will give a gift. That is the number of the people. So you will divide it to 3 people. Okay, so these are 3 people who will receive money would be Laura, Owen, and Vic. So this is the first transaction up to here. Second transaction is Owen will give away $500 to 1 people. That 1 people is Dave. That's the second transaction. Third transaction is will give away 150 to 2 people, Vic and Owen. This is the third transaction. Fourth transaction is Laura. You give away 0 money to 2 people. So these 2 people receive no money, but these are the 2 people who give. Last one would be Vic, who give away no money to no people. Okay, so this one is the description of the input. So what happened is that you totally have 1 transaction, 2 transaction, 3 transaction, 4 transaction, 5 transaction. So this one The greedy giver is a transaction based. You need to finish all of the transactions. Okay, you need to finish all of the transactions. And in order to, and then at the end, you actually provide the output of the net money that each one has. So at the end, Dave have $302, Laura lease, and Owen has negative lease. So he actually Owen give more money than he received. Okay, so initially everybody has zero money. And then once you got deduction, you deduct the money. And then when you receive money, you increase the money. And then at the end, you got this total amount of money. So that's the money you will print now. Okay, so that's the money you will print now. Okay, anyway, this one is a transaction-based problem. Any questions so far?
No.
So Harrison, how to solve the problem?
We do like a for loop through like all like the lines and then lines in the file, and then we like check for if it has like a number, and then we iterate through the amount of times in the second number to like split the first number through, and then we like save the result in like the name, and if we come across a new name, we create like a new like object or like new array list thing.
Okay. So what type of data structure you think you will use?
What do you mean?
What type of data structure you will use?
Like un.
Data structure. You like to use array list, or anything else?
Array list.
Why array list?
Because it allows you to like easily add like a new name.
There's no new name. There's only 5 people.
Like like
Initially, you will know it's 5 people.
oh, so like I guess like array could also kind of work, or like hash map.
Which one?
Like me personally, I probably use like array list.
Array list is not a good one. How about Jiang? Jiang, did you work on this one before?
If it was me, I think I'm gonna use hash map.
Hmm. Have you worked on this problem before or no? Hello? Anybody work on this problem already?
I'm done with it.
Okay, this is competitive programming, so you are supposed to get started for the training course. Okay, if you haven't, you should. Otherwise, you are not following this course. Just coming to here for lecture doesn't help you. Okay, it will not help you. This is a competitive programming course. So core stuff is you need to train yourself. My job is coaching you, helping you to grow. My job is not giving you the answer for each problem, okay? That's not the purpose of the training. Hear me?
Yeah. Yeah.
So if you don't have account, you have to open the account and get started by yourself. And then up to here, last time I talked about it, you have to at least submit the test program. Okay? If you haven't do that, please do it, okay? Otherwise, you will not be able to follow this course. Okay? Don't just sit there and waiting for people to tell you what's the story. You hear a lot of story, it doesn't help you because it's not programming. Key point is the problem solving part. Okay, this one you actually have 5 people and then each of the name actually each of the name you actually have what? These are 5 people, Dave, Laura, whatever, okay? When they have the input, it's actually using name. So you need to distribute the money to the 3 people using the name, okay? So let's see. So at the end, you want to print out according to Dave, Laura, Owen, Vic, and So you following the order. So there is something that you need to give the money to. So I think you still need to have something like an array that would solve the problem. But array by itself, you actually right here, you actually this one, you have a Dave, then let's see. You use let's say you actually have the name. You use the name and you do transaction, but the name is not a good thing for indexing. So you will use index. So right here, I'll suggest you to use at least using a map between the name and the index, using it as a reverse array. That would be an easier way to do it. Okay, so the bank account, you can still use array. And then the name, you can also use a array of strings for the name. But between the index and the name, I would prefer to use a map. Okay, that's the planning should be. And then you actually update your transaction among the arrays and eventually print out the arrays amount. Okay, print out the arrays amount. So let's do it. So this one I'm going to copy from here. We have write the program. Last time we actually work on this write program. So right here, I'm going to create a new one. This one called gift one. I'm going to copy everything from this write program. I just want to get the template. I don't need anything else. Okay. And then this class is gift one. Okay, so here task change it to gift one. If you are working on a newer problem set, there's no need to change this header. But existing system, they do need that, okay? So here, let's change to gift one. Gift one, okay? So get started. After that, anything else we don't need, let's actually delete all of them. Okay, so this one, we get started with this. Before we do coding, let's actually work on the test patterns. So this one I call it chapter 6B because last time we used a chapter 6, so I use a chapter 6B. So right here, I'm going to create a new file. And I'm going to save as because it's input file, so I'm going to change it to O type. And I'm going to save it to this one, chapter 6B. It's O type here. You need to keep it as an O type. And then keep it to give one dot in. Okay, get the keep one dot in. And then now I'm going to go to the website. I'm not going to use my file. So what I will do is actually copy this whole thing into the Git one to here. I'm sorry. Not here, should be here. Okay, so this is the input file. Okay, input file called Git one. So let's actually save. Okay. Now I got this file. Before we do anything, let's do this. We have a scanner, so let's do while input that has next. So let's read in line by line and then print it. Just do it that way, okay? Making sure we read in the right data. In the competition, you don't need to do this, but here I'm just trying to be safe. Okay, so the data being read in, that's no problem now. Okay, we are going to modify it. So the first thing is that the first line is the number of the people. It's called NP. So you can use NP or use N. I would use N, okay? So let's do this. Let's have the integer N equal input dot next int. I don't want to do next int, so I'll do integer dot parse int with the input the next line. Okay, making sure that there's no fit through problem. So now I got an N, I know N, so let's do this. Let's do integer, okay, bank. So bank is an array. So there are totally N number of the people. Each one has a bank account. So this one is the bank account. And initially everybody should be 0. That's no problem. Now next one is a string array name. Okay, these are different names. Now next one, you also want to have a map string integer. This one is called m equals new hash map. Okay, so this one creating the relationship between the two. Now you already read in the N. Next one, you are going to read in all the name for the for it. So let's do this for integer I equal 0, I less than N, I increase. Okay, so names I equals input the next line. So you read in every single name into the names, okay? And then you also would do your M, you would do your M dot put your names I with I. Okay, this is the relationship of your creating your reverse array. Okay, and the rest of them you do this, there's no problem. Now, after we finish this, let's do this system that out the print line arrays the two strings of the names system that out the print line arrays back to string of the things. And then let's do system.out.print line the map. So you actually read in a name of these, initial value of these, LoRa 1, tape 0, ON 2, ARM 4, weak 3. Okay, so this is reverse array being did right here. Okay, no problem. Now that's good. So we got that. The next one, we are going to work on the transactions. So up to here, these are not necessary. We can actually comment out these different lines. Now, next one, we go into we already read in, we basically read in number of people and all of the 5 people. Now we are going to work on the transaction based. Okay, so we are going to work on the transaction base. So we will work on each transaction and then, so now let's look at these numbers. You will read in a giver's name, and then you will actually read in the given amount. And then you will actually divide by the number of people you give to, and then each one of them who would receive money, okay? Okay, so let's do it. So right here, we actually, next one is actually, we go into the while loop. So first one is actually the giver. So string giver equals input the next line. That's a giver. And then the next line, we will read in 2 numbers. That 2 number will be a next one, we have 2 number. 2 number, one is the total amount will take away from the person, and then the 3 people that will give to, okay. So let's actually do this. Let's do this. Okay, let's do actually let's do integer amount equals input and let's integer. Integer R is number of the receivers. And then after these 2, we would actually change the line. So let's do input that next line, okay? Dumping the new line mark. And then after that, we will, based on the number of the people right here, to read in 3 people. Each one of them will receive the money. So we would do for integer j equal 0, j less than r, j increase this, we would read in 3 people, okay? So here we would have a string receiver. Okay, we read in each one of the receiver. Here I just try to test, okay? These are not necessary, but I just try to be safe. In real competition, I'm not going to do this. Okay, I check the amount and R, and then each receiver's name. Okay, so that's that. Let's see. No such element exception. Okay, the last one you have a week. The last one you have a week. Here you have. So remember, last one there is a zero. Let's see. Be careful about the zero part. Here you have this one, the last one, you have arm and week, and then the week would have zero amount. So that will create trouble over there. Okay, let's see. So right here, let's see. So if R equals zero, you will continue. You will not actually continue for anything else. Okay. Okay, so that solved the problem. So let's see, 203 people here, 501 people here, 152 people here, and then $0 people here, okay? And the rest of them, the week doesn't give away any money. So this one continue is okay. So this one, so far, we actually read in the right data. Now we are going to do transactions. We are going to do transactions. So we do have the amount and the amount of people. Okay, so these two, we can actually bypass them. But before we give away the money, we would actually update the people's amounts. So we have a giver, we know the giver, so let's do, let's see. We have the amount, okay? So let's see, your giver will actually deduct by the amount. So your bank, okay, M dot get giver. Giver is the name, and you will get from the map to the have an index. That will be the bank index. So this number will be deducted by the amount. Okay, but it will actually add the amount, take modular by R. That's the remaining part. Okay, that's the remaining part. This one is after the transaction, the giver will become this much money. Now let's look at the receiver. The receiver, the bank of the M, the get receiver, okay, will be plus equal amount divided by R. That's the divided by 3 people. You get the integer amount of that money. And this one, we don't need that. So after this different transaction, we are going to print out every single person's amount. So that's 2 for integer I equal 0, I less than n, okay, I increase. And then we do system that out the print line of the names I plus plus space bank I. That's it. That's a check. Check that with the expected output. 30266. So this one is wrong. How come that one is wrong? Everything else is correct. Now let's see. It's also possible that the amount can be 0. Okay, here the amount can be 0. So here, this one, okay. So if amount is 0, also no transaction. So if amount equals 0, let's also do continue. Actually, there's no transaction also. Let's see, let's try this one now. One more time. Something wrong? Input mismatch. Let me take out this one. Oh, there is still need to get it. I'm sorry. This one cannot work this way. Let me do it this way. Okay, let's do this. There's something wrong. I'm not sure what's wrong, but let's do this. Let's don't do it here. Let's put this for loop inside here. So A/B transaction, we print out the net result for each person. And at the very end, we also print out once. Let's do this right here, okay? To check if there's something wrong, something that we forget. I think there's a minor issue that I make a mistake somewhere. But it's okay, let's run it. Okay, let's see. Let's look at the so after first transaction, Dave is I think I make a mistake right there. it's actually +2. So that's the equation that I'm using is wrong. I'm sorry. So here it actually, this one, let me redo it, okay? This one, that's actually just, this one, that's minus, it's not plus. Because you will receive this one back, it's not actually deduct furthermore. Okay, let's do this way. Okay, I think I found the bug. Okay, so I think this time it's correct now. Okay, so everything is correct. Let me actually, these are not necessary. Let's delete it. This is not necessary. Let's delete it. Okay, let's actually just keep this. Okay, that's the result that we expect. Now you want to send to the output file. That's actually, you need a system that, and let's run one more time. Okay, so now it's time to submit. Your program is printed to standard error, input mismatch. Compiling okay, your program may exit with 1. Some of the input is wrong. Let me see. Let me run one more time. Let me take out these are not needed. Let's take out. These are not needed. Let's take out. Let me check. It's an IO issue. Keep one that out, new file. Input line. Let me make sure I print out the right data. Let me read the output. You want the out. I think it's okay. Your program printed data to standard error. Type of mismatch. There's some problem with next integer. Okay, I'll submit one more time, okay? And then I'll try to remove the it said that it's actually related to the next integer. So I'm going to remove those next integer, okay? I'm going to try again. Let me try one more time. Okay, still have trouble. Let me multiply it, okay? I'm not sure what's going on, but since it complained with the input integer, so it can be because of here, I think, okay? So let's do this. That's actually, you read in a line for the giver, that's the name. And then the next line, let's have that's read in a line. Just don't use the next integer. That's actually, let's do this. Let me actually try to, let's comment out this one. Let me change everything to next, just next. Don't use the next line. Let's use just next. Because user code don't like the complex text input. So that I would change everything to next and next integer. Okay, there's no more next line. Let's try. Let's try one more time, okay? Okay, it passed. So, I mean, here, next line, I am supposed to, I think it's okay, but somehow it just doesn't go through, okay? So I delete that line, just read each character, each token at a time, okay? Why? I don't know, but you have to make sure that the server work, okay? Any question?
No.
This one is a transaction-based design. So let's see, let's review this problem. You prepare the input output, read in the number of the people, right? Here, I have a bank integer array, a string integer array. You need this, right? Because each person, you need to have an order. You need to have an order of the name. But at the same time, you also want to know that given a name, you want to know about the index to access the bank address. So this map will help you to solve the problem. This map would be a reverse array from string to index, from string to index. Okay, that will save you time. And at the end, because you want to print out the name of the bank, so you still need to have the array for the name of the person. So you don't need to search. You cannot just use a map. Use a map, you actually have no order. You need to have an order. So you actually still use the array. That would be better. But because you use the map, so when you try to access the bank index for the giver and receiver, that would be faster by doing this. Okay. Any question?
No.
So this one is a transaction-based algorithm, and you based on each transaction to process the problem. So we call this one a ad hoc solution. So when we say ad hoc, means that it is a specific way of solving the problem, and you solve the problem by this way would be the best. So we call it ad hoc solution. Okay, we call it ad hoc solution. Okay, this is deep keeper. Let's look at another problem. This problem called 2014 December bronze problem 1 marathon. Okay, let's work on this one. This one is an easy problem, so we put it in the early part of the training course. So problem solving, there's no specific way of solving the problem. No one will tell you which way you should do it, but you have to figure out a way to solve the problem. Okay. So previous one is transaction based. It doesn't mean that every problem can be solved by that way. Okay. So let's look at this December 2014 bronze problem 1 marathon. So unhappy poor health of his cow. Farmer Jones enrolled the cow to a physical fitness activity. His prize cow Basie is enrolled in the running class, where she is eventually expected to run a marathon through the downtown area of the city near Farmer John's farm. The marathon course consists of N checkpoints. So you have a marathon route from here to here to here to here to here. So let's assume this is 1 checkpoint, 2 checkpoint, 3 checkpoint, 4 checkpoint, 5 checkpoint. Okay, totally 5 checkpoint. You run a marathon, you need to go through this different checkpoint in order to get checked, making sure that you don't go anywhere else. Okay. So where checkpoint 1 is the starting point and N is the finish, Basie is supposed to visit all of the checkpoint one by one, but being lazy cow, she would actually skip up 1 checkpoint at most. So you have 1, 2, 3, 4, 5. You go all the way to here, okay, but you can skip one of them. So you can do, let's assume that you skip the second one. You actually go here to here and then this. That's one way you can run it. Or let's assume that you actually skip this one. So you go here, here, and then jump to here and jump to here. Okay, so you can skip one of them. Now the question is, they are using this distance of delta x plus delta y. Okay. This we call it city block distance. So what is city block distance? Let's assume that you actually has 2 locations. You want to measure the distance. So the distance can be square root of x1 minus x2 square plus y1 minus y2 square. This one is called Euclidean distance. But in the problem we are doing is not using this Euclidean distance. We are talking about city block system. What is a city block system? This one is actually, let's assume here you have a x 0.1 and you have a 0.2. Then it's measured by number of city block you need to go through. How many blocks? So it's a delta x absolutely plus delta y. Okay? Is that okay?
Yeah.
So the system is measured by the city block, not measured by the Euclidean distance. Now, you have 4 points. Coordinate is 0, 0, 8, 3, 11, minus 1, and then 10, 0. Okay, these are the coordinates. And you can skip, so this one is the starting point, this one is the ending point. And then you can skip one of them, and then the question is, output the minimum distance that Basie will run by skipping 1 checkpoint. So you can skip this one or skip this one. Starting point you cannot skip. The ending point you cannot skip. You can skip this one and you can skip this one, and then and then calculate the minimum distance. Okay, this one. For Stephen, how to solve this problem?
Oh wait, can I see the input format? Yeah, this like maybe you have to calculate like the distance and then put it in like an array. And wait, let me see.
How about Jiang, how to solve this problem?
I still can't kind of understand the question though.
The question?
Yeah.
The question, you have these so many points. So each one, the coordinates, this. Then we actually is actually 0.1, 0.2, 0.3, 0.4. And then you can skip one of them, but you can go this way, this way, this way, or you can go from here to here to here. You can skip one point, but which way would be the shortest distance for the complete the whole route with only skipping one point? This one is an AHA problem, okay? So Jiang, do you understand the problem now or no?
I understand it now.
Okay, you think about it, okay? How about Kingston, how to solve this problem?
There's only like 100,000 checkpoints, so you can just loop through all of them and remove them and check like the distance it saves. So you calculate the total distance between the 3 checkpoints that you're like you calculate the original distance and then you remove each checkpoint and calculate the distance you save, and you remove the one that saves the most.
Correct. So this one, the way to solve the problem is like, let's assume that you have 1, 2, 3, 4, 5, right? You actually have 5 points. You actually will run like this. So you calculate the total distance for the 5 point. You go through each city block distance by this. Then you go through each individual one. You don't go this one. You go from this one. You cut this one, so you actually you add this one but delete these two, and then see how much you save. Okay, that's the first saving you can have. Now second saving is that you actually try to skip this point. So you add this one but remove these two. See how much you save. So you actually try to see which one you save the most. and that will give you the minimum distance. Is that okay?
Yeah.
Okay, so this one is pretty simple one. So this one is a 2014 December. Let's look at the problem set, okay? And we will work on it. I'll give you the idea of how to submit to the older problem because we haven't, so far we only work on the user code gateway, the training site, but we haven't worked on this website, okay? So let's look at the training and let's go to 2014 December. I think 2014 December is this one. Okay, and you will go to bronze, marathon is this one. So you come with the solution, test data, and problem. So never look at the solution. If you haven't studied, don't look at the solution. You try the problem first. And then if there are certain test pattern you cannot solve, there are test data you can look at. Okay, you check this one. Only when you struggle for the long time, you still cannot solve the problem. You look at the solution. Okay. Now, anyway, you go through this view problem. Okay. I solved this problem before. Anyway, so now we are going to work on this one. So I'm going to create a new class. This one, let's call it marathon. It's lowercase, okay, because they like lowercase for some reason. I'm not sure why, but they like the lowercase. So I'm going to copy this one from this keyboard number 1, okay. Put it over here. I'm going to copy the name marathon to here and here. And then the two input and output file name need to be modified. Okay, and then these, we can delete them. So usually a new problem, you need to modify here, 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 4 different locations. Okay, anything else that's deleted, we don't need that. We actually will have different things. Okay, the deck is ready. Now, before we work on this problem, that's also created the test pattern. So the pattern, let's create a new file. And then let's copy this sample input. Put it over here. Okay, these are the new, let's save as this one, change to all type. Let's change to marathon.in. Okay. Okay, so this one got the marathon.in now. Now, it said the point is from 1 to n, but it's okay. It actually 1 to n or 0 to n minus 1. It doesn't matter. Okay. So here you first will read in integer n equals input the next integer. Okay. And then it will give you 2 coordinates for each of the points. So let's do this. Let's do, you would have x and y. So let's do integer array x equals new integer n integer array y equals new integer n. So these are n points for x and y. For integer I equals 0, I less than n, I increased. And you read in for all of the x and y, so x I equals input that next integer y I equals input that next integer. Okay, and you want to calculate the total distance. So let's do, you got all of the point, okay, stored into the xy. Now you want to calculate distance. So let's do integer total equals 0 for integer I equals 0, I less than n minus 1. This one you will do the distance between 2 points. So up to n minus 1 is a window of 2. Okay, so you come up with the total distance for the whole route. Now you're starting to actually do the skip, okay? So integer maximum equals 0, okay? And then you will do this, you will do for integer I equals 1, I less than n minus 1. Okay, these are the points that you can skip. I increase. So each I is the point you will skip, okay? So you skip, then you will actually remove two distance. Let's assume that you are actually point I, okay, point 1. So you have the 0, 1, and 2. So you will add these two and then deduct these two, okay? So let's do this, that you will have the integer t1 will be equal to mass dot abs of the x I minus x I minus 1 plus mass the abs y I minus y I minus 1. Okay, so this one is the distance of this one, okay? And then you have the distance 2. And distance 2 will be between I and I plus 1. Okay. And then you have also have the distance 3. Okay, distance 3 would be I plus 1 and I minus 1. Okay. So your total amount of deduction should be total amount of deduction is D1 plus D2 minus D3. Okay, so if DD greater than maximum, the maximum would be equal to DD. Okay, and then you will eventually you will get the maximum deduction at the max. So your system that out the green line, your total minus next. $14, okay? 14 is the number that you get from here, okay? So 14, then what we would do is to take out this system that you must practice yourself, okay? If you just listen to me, you are not going to do any, you're not going to solve any problem, okay? So choose Java. And then choose this one, marathon. Oh, EPAS is not super fast. If you want to reduce the algorithm, I'm sure there's a certain way you can make it faster or change language, okay? Is that okay so far?
Yeah.
This marathon is, you can also call it transaction based because each time you remove two sections, okay? You remove two sections, adding one section to bypass it. Okay, you actually every single one you do that, and you go through every single one of them. So it's similar to transition based, but a little bit easier than the transition based. Okay. And here we are talking about the ETA problem, and here we give you two examples for ETA problem. One is the gatekeeper, another one is this marathon. Okay, let's move on to the next one, next chapter. You must work on it, okay? If you don't work on it, you are not going to learn anything. So don't complain that later you tell me, oh, I'm not able to solve this problem, I'm not able to solve that problem. That's your own issue, okay? This is competitive programming. You need to train yourself for all kinds of problem. That's not my job to help you to solve the problem. It's your own problem. You need to solve them. Okay? Just like you go to the marathon running, every week you need to run for 3 miles. You got to train yourself. I'm a coach. I don't run for you. You run for yourself. Okay. Okay. Now we move on to the chapter 7, search of the solution space. Search for the solution space. First, you need to know about the solution space. There's a few words, solution space. There's another word called workspace. These are different terminology in computer science. Okay, you need to understand them before you can knowing what's going on here. Okay. So ECHA problem, we talk about ECHA problem. Now we moving on to we will talk about Friday the 13th is also a ECHA problem. We'll solve it later, okay? But now we are going to talking about the search problem. And we go for the complete search before we actually talk about other type of searching. So we first will talk about the complete search. So before the complete search, you need to know about what is the solution space. Okay, last time we talked about the minimum of x minus 4 absolute value, the minimum of these. Let's assume that x greater than 0 and less than 10. Okay, this is actually the solution space. You are looking for the solution from 0 to 10. These are the solution space we search for. How many variables are here? Is only one variable. Okay, and x minus 4. So when you x equals 4, the absolute value should be 0. So this chart apparently is a mirror line like this. So minimum happen down here. If you study it, okay, if you study it like that. But sometimes the goal function is not so easy. So you need to know about what kind of problem you face for. So right here, you don't go through every problem solution. You just need to go through this one, this one, this one, because the monotonically decreasing and monotonically increasing. So the maximum point or minimum point can only happen on the boundary or the turn point, because it had the monotonic decreasing and monotonic decreasing. So the turn point can also be the maximum or minimum point. So this problem, you check 3 points will be enough. But sometimes you're not so lucky because the goal function is not so simple, may not be monotonic increasing or monotonic decreasing. So you would have to work on some question like this. Then we go this way, keep going down. This we call it gradient descent. To solve the minimum point. Here your gradient descent will go to his point. This one is a local minimum. Okay, this one is a local optimum. Okay, so if you use a gradient descent, you will find the local minimum. Instead, what math teach you gradient descent?
Calculus.
Yeah, calculus will teach you gradient descent. Okay, multi-variable calculus will give you the gradient descent in multiple variable space. Okay, so gradient descent is used to solve the problem for many of minimization or maximization problem. Okay, so this is 1D space, but sometimes you may have two-dimensional space, and your energy function can be like this in two-dimensional space. So the solution that you search for the solution for the maximum or minimum, we call it solution space. Okay, that's called solution space. Let's assume that, okay, let's look at another problem. Let's look at the tic-tac-toe game. So tic-tac-toe game, you may have put in a stone of the circle in the middle. And after that, you may have a possible location. So here, or you may go across here, or you may go across here, or you may go across here. Whatever it is, all possible, a possible solution. So first step, you put the stone in the middle, then you have this. And then this one, after that, you may have 7 different branches for the second circle. And then you may have 6 more for the cross. So you'll be 9 for the circle, 8 for the cross, 7 for the circle, 6 for the cross, and then keep going down until only one solution. So this one totally, there will be 9 band solutions, possible branches. If you look into the whole solution to see which one will give you the optimal solution, then that's called complete search. Complete search. Complete search means that you consider every branch of the solution, every single branch of the solution. Then that's called complete search. So to look at this one, you actually have the complete search. If you play the tic-tac-toe game, the complete search is 9 band. Okay, let's look at the robot problem. So a robot problem, you may have, let's assume that you have a rotary. So this one you may have a variable of the theta. And then there's a second robot arm right here. Here you have another theta. And then your end point right here, you have a robot finger right here, okay? So you have a theta 1, theta 2. You use the theta 1 and theta 2 to control your robot arm. And this one, the plenary robot. So your space is the theta 1 and theta 2. Use the theta 1, theta 2, two variable to control your robot. So this robot, we call it a degree of freedom of 2. Okay, if you control that robot, it's a degree of freedom of 2. That is your solution space. Your solution space is based on the variable that control your solution. Is that okay?
Yes.
That's called solution space. And this endpoint may have the XYZ for your robot finger. So where this finger can go to, we call it workspace. So workspace is different from your solution space. Solution space is based on your variable theta 1, theta 2. You control it to find a solution. And your workspace is the wherever you can reach by your XYZ, your finger. That's called your workspace. These two are different. Workspace means, okay, so let's assume that the workspace for this 2 rotary robot, then it's like this. If you don't move the second one, your second one, theta 2, is always keep at the 0. Then this one is more or less like a baseball bat. You just have the theta 1 and you swing it. You will swing as a circle. That's your workspace. If your theta 2 is 0. Is that okay so far?
Yep.
If your theta 2 is not 0, then it's actually you can swing different route. And then you can control where you swing your robot arm to. Okay, that's the robot control. But anyway, this one we talk about is that in the robot, you have the workspace, you have solution space. And in this kind of competitive programming, you also have the solution space and the workspace. So here, before you actually look into your problem, you need to know about what is your solution space. Okay. So for example, this one, your x minus 4 absolute value, your x greater than equal to 0, less than equals to 10, your solution space from 0 to 10, you only look at the solution in this region. So one way you can do it is that you go through every single point. That is called complete search. But another one is that you, based on your linear programming experience, you look at the boundary points, then you save your time. So which way you solve your problem, complete search or not complete search? It is a decision. Sometimes complete search is good enough. Okay? Is that okay?
Yeah.
So by the way, AI, what is AI? What really is AI? You do Jason Huang's CPU, the NVIDIA's CPU, GPU. You do training, you do AI. So AI usually is just brute force to search through the complete solution to find an answer. So that's why AI usually use a lot of power. Because AI is not human, so AI doesn't jump to the conclusion. AI actually just go through every single possible solution and then give you the which one match the solution the best. So usually AI is wholly searching for the solution space. So if AI is not good enough, your chip is not good enough, then people say, let's do quantum. So quantum is also another way to do complete search. Is that okay so far?
Yep.
So ad hoc solution is to solve the problem based on a certain specific way to do it, while complete search is to go through the whole solution space to check each individual possible solution to do it. Okay, we are going to talk about this Friday later, okay? We have too many problems. So let's look at the complete search first. So problem solving loop. First, you need to identify the problem. What is the problem you want to solve? Second, you will actually check the idea, create idea. If you don't have idea, you basically cannot do any problem solving. And then you search for the best idea and you work on the idea and test on it. And then you evaluate your result. Okay, so this cycle is your problem solving cycle. So complete search, first you need to go through all possible solution space to find out which one may give you the best answer. We don't know, so we go through every single one. So depending on the solution space, it may be order n, maybe order n log n, maybe order n squared, depending on the solution space size. Okay, we evaluate all possibility. That's called complete search. So first one is the subset. Okay. So let's assume that we have binary 0, 1. So let's assume that 4-bit, and we only have the binary. So how many possible symbols that we can create the 4-bit string using the binary symbols? For Jiang, how many symbols we can create?
What do you mean, how many symbol?
What do I mean? I'm thinking about for almost 1 hour. What do I mean?
Like, oh,
Are you listening?
yeah.
Yeah. So for 4-bit 0, 1 string, how many symbol can you create?
Wait, 4-bit with a binary is about 16, I think.
So you do 2 to the power 4, right?
Yeah.
So you are DNA, you have ACTDT. And then you each one of them, you have these. and then you have 4 of them. How many can you create? You can create 4 to the raise to the power 4, right? Because first one you have first symbol you can be ACTG. Second one you also had the choice of ACTG. So totally you would end up this. That's a total solution space you will end up with, okay? So first one, you have a set of 1, 2, 3, and you want to generate all of the subset. So how many subsets are there? This one for Harrison, you have a set of 1, 2, 3. Then how many subsets are there? Totally possible subset. Harrison, are you hearing? Hello? My speaker has no problem. Harrison, can you say again? You have to check your microphone, okay? I don't hear you. Okay, anyway, how about Kirsten? You have 3 members in the set. How many possible subsets are there?
8.
How to generate them?
You go you generate so there's 8 because it's 2 to the power 3, right? So you can either include the number or not include it. So
Mhm.
you loop through all the possibilities for it's
How,
like bits.
how can you loop through all the possibilities?
So the first possibility is nothing, so it's 0, 0, 0, and then 0, 0, 1 means you include 3, and then 0, 1, 0 is you include 2, and then 0, 1, 1 is 2 and 3. And then you just loop through all the bits possible. And if the position has a 1, then you include that number.
So how can you write a program to do that?
You have like a for loop. You have a for loop, so a nested for loop 3 times, and each one goes twice, so from 0 to 1.
No, not 3 times. 3 times won't solve it. 3 times won't solve it. So this one does assume that you want to create all the subset for 1, 2, 3, okay? Let's do this. Okay, let's represent a set by a string. Okay, so this one you have the ABC. So the subset you create would be empty string A, B, C. That's 1 letter string, and then AB, AC, BC. That's 2 letter string, and then another one is ABC. So totally 8 possible substring or subset. Is that okay? Hello, is
Yeah.
that okay?
Yeah.
Now question is how to create all of them. Because you want to go to the whole solution space, then how to create all the possible subset combinations? So you know you have the n, that's actually your number of the integer, okay? Your length of the set is 3, so n is 3. So you want to go to integer I equals 0, I less than mass the power of the 2 raised to the number n. So this one, if n equals 3 here, it should be 2 to the power 3, it should be 8 possibilities. So your I starting from 0 to the 2 to the power n. Okay. Then your string s equal to converting your I to base 2. So here's the why I converted to base 2.
So it's the binary representation for it, and then you can just check the position for the 1 or 0.
So if here this I is 7, you become 1, 1, 1, right? That's the purpose.
Yep.
So now you have each digit using the 0 or 1 to determine whether the data should be included or not. Okay, so let's do this. Let's do string data equals empty string. Okay, for actually integer j equals 0, j less than s the length. Okay, j increase. Okay, if s the character at j equals 1, it can only be 0 or 1. So if it equals 1, then actually data plus equals set the character at j. Is that okay?
Yeah.
Data may be empty, so I want to create extra indicator to make sure it's okay. Okay, so every single possibility. So if you want to collect them, then you actually can do this. You can create array list of string. Okay, by doing this way, you actually generate all possible subset of the ABC, or you can call it substring. Okay, let's give you the solution space. Any questions so far? This is necessary if you want to go through all the subset. Okay, so right here we give you the idea of what is the solution space and give you the idea of how to create the all possible subset. Today we'll stop here. Next week we will talk about going through all the possible combinations and permutations and pairing. Okay, that's a different solution space that you can generate. So today we actually, if you do C language, C double plus language, it's way easier. Okay, this is the way to generate a subset using the bit level operation. Okay. Anyway, that's it for today. Okay. Any questions so far?
No.
One more suggestion is, if you really want to do competitive programming, you do need to practice yourself. Okay. Every week, at least 3 problems. If you are below that, you cannot compete. Okay. Okay. Anyway, that's it for today. Good night, and next week we'll continue to work on other possible solution space. Today we just touch base on the subset. Next week we'll go all of these. Okay, and then we'll go back to the Friday the 13th problem. Okay. Okay.
Okay.
No question. That's it for today. Good night, and bye bye.
All right. Thank you. Bye bye.
Bye bye.
Yeah.